Welcome back, everybody. Mr. Diamond again, and we're going to pick up right where I left off in that last video, where we're now going to talk about constitutional or structural isomers. This is when the molecules are made out of the same pieces, you just assemble them in a different way. So we said isomers, just to make sure that we're all on the same page again, are when two chemical formulas can result in equally valid chemical structures. So take these ones, for example, here. They're both made out of 1, 2, 3, 4, 5 carbons, and then 1, 2, 3, 4, 5 carbons. They both have an oxygen, they have an oxygen, and then if we add up the hydrogens, we would also find that the hydrogens are equal between these. So they would have the same chemical structure, but they're actually different. This one would have been 1, 2. This would be 1, 2, 3, 4, 5 pent 2-ol, and this would be pent 3-ol. So that's actually two completely different structures, but they're made out of the exact same pieces. It's kind of like Legos. You can take Legos and you can assemble them a whole bunch of different ways, even if the pieces are going to be exactly the same. So notice that while they have the same formula, again, C5H12O, they are actually different molecules. So questions could be phrased kind of like this. Identify the constitutional isomers below, and in doing that, you're going to have to actually look at the pieces, and you're going to have to identify, well, I've got 1, 2, 3 carbons, 1, 2, 3 carbons, 1, 2, 3 carbons, and 1, 2, 3 carbons. Okay, they all have 3 carbons, and they all have 1 oxygen. It looks like my big key in this one is going to actually be hydrogens. They have to match exactly the same stuff that they're made out of. So here I've got 3, 4, 5, 6, 7, 8. And here I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So these three are all constitutional isomers, and this one is not. So all three of those will be constitutional isomers because they're made out of the exact same pieces. One important note, though, make sure that you're not accidentally calling a molecule an isomer when it's actually the same molecule. Isomers have to be two things that are different. They just are put together in a different way, or they're made out of the same pieces. So they're different but put together in an order that makes them different, not the actual pieces that make them different. So an example, just to kind of show you a little bit more tactically or tactily what I'm talking about. So here I have a molecule, and if I actually go back, I can modify this really quick, and we can make this look exactly like the one that I've got in this example here. We're taking these pieces, we're taking this molecule, and all we're doing is we're just rearranging them. So like I'm taking, for one here, I'm going to rip off this hydrogen and this, and I'm going to attach them together. And if I hold it up kind of at an angle there, you can see that it's got the two things that are over on this side over here. It's got that shape to it. It's a little bit bent off, but it's got that shape to it. I can then reassemble it going in a straight line if I wanted to. And that's if I make sure I've got it going the same direction. That's this piece right here. That's just a straight line. And then for that bottom one, I would just take off this piece right here, and then we'll take off this piece right here, and we'll have them swap places. And if these guys swap places, so it's weird because I assume when you first started playing with these, you thought they were kind of like Lego sets, and this feels a lot like Legos, where you're just you're rearranging and you're mashing up and you're kind of putting together. But all of these are examples of constitutional isomers. It's their constitution, their order of how they are put together that is actually different, not their composition. They're made out of all of the exact same pieces. I believe that's where this section leaves off. So again, just make sure that when you look at them, you have to make sure you remember that single bonds can rotate. So like I said with my examples in the earlier video where I've got my red molecule and my blue molecule, just looking at this versus looking at this, you may go, okay, well, those are different, so they're isomers. You have to make sure you kind of do some mental gymnastics of, well, if I try to, can I get them to position the same way? And I can, in fact, do that. I can get them to be positioned in the exact same way. So because of that, they're not actually isomers. They would be identical molecules to one another because they're both able to do the same thing. All right, that's where I'm going to leave off this video. Again, I mentioned the last one. I know it's kind of short, but I want to keep these separated from each other so you can go back, especially because you may need some of these next chapter as well. In the meantime, though, this is Mr. Diamond signing off. Hope you have a good rest of your day. Let me know if you got any questions.